Hello, today we're going to be doing some Fulldome Fisheye rendering with Blender. I will help you walk through the setup of the camera, and then we'll make a nice starry background with constellation lines like you see here. As we get started, I'll introduce myself. I'm Ron Proctor. I have over 20 years of experience with Blender in planetariums and also in museums and other organizations. So if you or your team would like to upskill with Blender, I am someone that can help you with that. Go ahead and reach out on LinkedIn, or you can reach me on proctorcreative.com. But let's go ahead and get started. So here we are in Blender, and a lot of what we do is going to happen over on this panel, so I will hide myself. And for fisheye rendering, the first thing we need to do is get rid of stuff in the scene that we don't need. So I'm going to delete the default cube and also that light. We're going to take EV and change it to cycles. This only works with cycles. Now, I'm going to be rendering on my GPU, and you might have that option, or hopefully you do have that option. You can configure that up here in Edit, Preferences. Oops, let's bring it over here so you can see it. Go to System, and if you have an NVIDIA card, you can enable that and also enable your CPU. And under optics, that combination performs really well for me. If you're on a Mac, if you're on an M series Mac, I would only enable the graphics card, but not the CPU, because if you do, your Mac will become kind of useless while it's rendering. So at least that's the advice that is going around and that I've seen in my own experience. So let's continue our setup. Scrolling down these render settings, we see we have a sampling zone here for the viewport and for the render. This is where you can tune in your render times and make them go a little bit faster. I never need this to be less than 0.03, and I typically don't need this many samples. I'm going to leave these alone for now because we're not talking about optimizing renders today. We're getting set up for just the basics. I do not need denoise, and I do find that denoise will kind of complicate animated renders because you get different denoise results from frame to frame. So I typically will turn that off. Light paths, this is another place where you can improve your render times by making these numbers smaller, but I'm going to leave those alone for now. Another one just to be aware of is under film, you can click transparent if you want a transparent background, but we're not doing that this time. Color management. This has become really important. If you need to match the colors of your input graphics to your output, in other words, if your output needs to match your input, you might want to change this to standard. And then you need to also make sure that your inputs are set correctly, but I'll show you that in just a minute. And I'll also come back to this and show you the difference. Output parameters, output properties. Let's scroll back to the top here. Now, when we're rendering for fisheye, we render in a square. And a lot of you will have planetariums that are 2K or 4K, maybe even bigger. But for this demo, we're just going to keep it 1K so it renders nice and fast for us. Frame rate, we'll go with 30, although I will not be animating today. I'm not going to mess with these, but this is where you can change your frame range, make your scene longer. Output. This one is, this is where you will select where the output of your render process goes. I find that I like to set the default to //frames/frame underscore. And what that does is that makes a directory called frames right next to your blend file. So when you save your blend file, and then you render, you'll get a directory called frames right next to it, and each frame will be named frame underscore and then some serial number. Lately, I have been rendering with EXR. Today I'm not going to render with alpha, but I can select alpha if I need a background that has alpha. I do not need more than 16 bits of color depth, so I will go to float half. Codec, I will use DWAA because it is very performant. And also watch out for post-processing. There's a dither in there, and if you don't want that, you can turn that down, which I often want to turn that down. Okay. Now let's work on this actual camera. We're set in cycles. So let's get the camera moved to the center of the scene. So there it is pointing straight up, and the X direction is positive to the right. So when we put our stars in there, we should see Polaris straight above us, and off to the right, we should see Pisces, which is near the vernal equinox. So, by the way, let's get something to render. Let me show you what this looks like just right now. Oh, I'm not done yet. So we're in render preview. I clicked on the camera. We're looking here, and we don't see a circle yet. So we need to go to our camera setting, our camera properties. Change this from perspective to panoramic. Notice that the regular fisheye that comes up, the default fisheye, is not correct. It leaves a big black rim around the edge. This is fisheye equisolid, which is used to model actual fisheye lenses on actual cameras. But we want fisheye equidistant, which takes that image all the way to the edge. Now, the next thing we'll do is take a look at some resources to give you so you can put some backgrounds into this. So the first resource I want to point out is NASA's Deep Star Maps, the Deep Star Maps 2020. You can just search for that, or I'll put a link in the description. This is going to give you the deep star maps in celestial coordinates, which makes the Milky Way kind of bend up and down. Or if I scroll down, you can also get it in galactic coordinates, which makes the Milky Way go straight across. It's important to decide which one you're working with and stick with it for each scene that you're working in. If I go to, let me go to another screen here. If we look carefully, we can see right up here near my little icon, you'll see a little star that's stretched out. That's Polaris. And if we took this picture, this is an equirectangular projection. If we took this picture and we grab the edges of it and pull them around until they meet, we would get a cylinder. And that would be a seamless cylinder. And you could put your head inside there and look around. Then what you could do is take those top edges and pull them in, and then you get a nice sphere. These edges, those top edges get more and more stretched out as you get higher and higher toward the poles. So yeah, let's put this into Blender. So we will need to go to the shading workflow. I'm going to click on shading up here at the top. And let's change this to a render preview and go to our camera view. Get a little room to work down here. I'm going to change from object to world because we're going to operate on the world material. Normally we'd have object here because we're doing object materials, but today we're going to work on the whole world material, meaning the background. So we already have the background color, and that can be any color you want. But we're going to assign that color with a node. So we're going to add a environment node or an environment texture node. I just clicked on add and then started typing env. I can plug that in, and the texture is missing, which is why it's pink. So now let's open and find our star map that we downloaded from NASA. And there it is. So we have our star map. We can activate the lock here and look around the star map. There's Orion there. What we're actually doing by doing this is we're moving the camera around. You can see that the rotations are all changed again. But if I put this back to 180, 0, 0, we'll be pointing straight up again. And Polaris will be right there. If you don't believe me, let's add the constellation lines now. So we're going to add another environment map. We'll do a Shift A this time, same as clicking add. Environment map, env, environment texture, I should say. And we'll open, find our constellation lines, open that, and now we need to add these together. So we could do this to replace the other map or this and get our other map back. But let's add an add color node. So Shift A, type in add. This will be a color, mix color, add node. Let's wire those together. And we can change this factor to something a little bit smaller, maybe 0.25, so that our lines aren't too overpowering. So at this point, we could render. Whoops. Come on now. And there's our fisheye render. We're ready to go with individual render image, which will give you just an individual image you can look at and save. Or if you're ready to do an animation, you can render your animation. Maybe you could rotate the camera and make it look like daily motion is happening for your latitude, for example. Or you could add objects to the scene. Maybe you put Earth in there. Make sure the pole is pointing up at Polaris. Okay, or at least to the North Celestial Pole, which is real close to Polaris. Okay, one other thing is this, let's stylize this and make it a little more colorful like I did at the start, that little example that I showed you. Let's add one more node. Add, whoops, and we will do a ramp, not ramp, curve, RGB curves, click, and I'm going to drop it on this wire. And what I can do is we can do lots of interesting things with this, but today I'm just doing simple mixing. So I'm going to take the red channel and I'm going to grab it up in the right hand top corner. I'm going to drop it down so it's flat. And see, that takes the red out of the RGB, so it's no longer white. Let's take some of that green away now. Drop that down about halfway, and that's a pretty pleasing blue. So there is your basic setup. I also want to point out one more resource. And while I'm doing this, I'd like to also, actually real quick before I point out the other resource, let's scroll down to the bottom of the NASA Deep Star Maps page. And you will see the credits, where it says, please give credit for this item to all these guys here. And please do that. I'll be adding this to my notes in the show notes there in the description, but it's really not a hard thing for you to add the credits. These folks work really hard to bring you this stuff for free. Now, let's look at another example of a nice sky map. This is over from Noir Lab. And full disclosure, I work at Noir Lab. And so I'm colleagues with these folks down here. And so please do give them credit. And this map is super cool. It's actually a photographic map of the whole sky. This is in galactic coordinates. So the North Star will not be straight up if you bring this one into Blender, but it's in galactic coordinates. And let's see, one other tip is you're bringing this in to make sure the color is right. You want to switch it to RGB, or excuse me, sRGB. So take it into Photoshop or Krita and switch it up to sRGB for the color space. Then in Blender, you'll import that as an sRGB image, and the colors will look awesome, just like you see right here. This Orion region, these deep reds, they'll come out really beautifully if you convert this to sRGB before you bring it into Blender. And that's just a quirk of Blender. It just handles it better if you do that. So make sure you credit them. And I'm trying to think if there was anything else I wanted to say. I think that's it. Oh, actually, no, I did forget. I was going to show you one more thing. And let me zoom in on this a little bit. So look carefully at the colors of the image. And I'm going to talk about the color space real fast in Blender. So as you change the view transform, that's going to affect the colors of your render results. So let's change this from standard to AGX, which is the typical transform. And you might actually prefer that in this case, although I do find that in other renders it will cause some images to have a washed out appearance. But anyway, AGX is your default. A lot of my colleagues are using ACES. But to get the colors to match as good as you can, to be true to the inputs, I've been sticking with standard, and then I make sure that that I'm honoring the actual color space that's in the file. So watch out for that, although Blender is getting better at handling colors. And yeah, so I want to thank you for watching. Go ahead and hit me up on LinkedIn or visit proctorcreative.com if I can help you out with anything, or send me a comment in the old comments there, and I'll respond as quickly as I can. Thank you for watching, and happy blending.